ये हम डिस्कस कर चुके हैं पहले. आई विल जस्ट गिव यू एन ब्रीफ ओवरव्यू अबाउट द asymptotic notations, and after that we will start understanding it. Okay, so basically there are three type of notations: big O, big omega, and big theta notation. Okay, whenever we are doing the performance analysis, then uh, we need performance analysis of an algorithm. So in that case, we need some type of measure to express the time complexity in different cases, like the best case, in the worst case, or in the average case. So if we want to represent the time complexity in the worst case, then for that purpose we are having this notation, that is big O notation. If we want to represent the time complexity of the best case, then we are having big omega notation. And if we want to means the last one, that is the in between the best case and worst case, that is the average case. Okay, so for that purpose we are having theta notation. So these are three notations which we simply use to express the time complexity in mathematical form. Now जैसे ये इसका प्लॉट ग्राफ था, ठीक है, तो अभी पहले मैं कुछ इसमें इनइक्वालिटी मेंशन कर देता हूँ, एंड आफ्टर दैट वी विल गो फॉर द numericals. So if we are talking about the big O notation, then big O notation simply express the upper bound on the algorithm's running time. तो इसमें क्या था, we are given suppose two positive functions f and g n. तो हमको क्या करना है, इनके बीच इनकी जो ग्रोथ है उस ग्रोथ को नोटेशन फॉर्म में मेंशन करना है कि हाउ द ग्रोथ ऑफ दीज फंक्शंस आर रिलेटेड विद ईच अदर. तो फॉर दिस पर्पस वी मस्ट हैव अ कांस्टेंट सी, जो हमारा इनइक्वालिटी अब हमको पे शो करना है, कांस्टेंट सी, एंड वन इंटीजर एन नॉट on what is the inequality. Inequality is this: 0 less than equal f, and it is in the case of big O notation, okay, and less than c gn for n greater than equal n नॉट. तो हमारे पास दो पॉजिटिव फंक्शंस हैं, एक कांस्टेंट है, एक इंटीजर है, और ये दो पॉजिटिव फंक्शंस इस तरह से रिलेटेड हैं, मींस फॉर ऑल द वैल्यूज और एट दिस ऑल द वैल्यूज ग्रेटर देन टू दिस एन नॉट, ग्रेटर देन इक्वल टू दिस एन नॉट, जो भी ये वैल्यू होगी इसके बाद वाली सारी वैल्यूज में दोनों फंक्शंस की ग्रोथ इस तरह से होगी. मीन्स द फंक्शन एफ एन विल ऑलवेज बी लेस देन और इक्वल टू सी जी एन आफ्टर दिस एन नोट. तो ग्राफिकल फॉर्म में अगर देखें तो ये हमारा एन नोट है, तो इस एन नोट से पहले both the functions can behave, or the growth of the functions can be in any form, but after this n naught the functions fn will always below the function cgn. और अगर ऐसा होता है और ये कांस्टेंट के लिए और इस वैल्यू के लिए, देन वी कैन से लाइक fn इज ऑर्डर ऑफ gn. तो हम इसको इस तरह से कह सकते हैं, ठीक है. सो ये बेसिकली क्या कर रहा है, इट इज जस्ट एक्सप्रेसिंग द अपर बाउंड कि भाई हाँ, इससे ज़्यादा टाइम, इतना टाइम तो लगना ही, इससे ज़्यादा टाइम नहीं लगेगा. दिस विल बी द लास्ट बाउंड और लास्ट वी कैन से डेडलाइन फॉर दैट. ओके, ऐसे ही ओमेगा नोटेशन में होता है. इन ओमेगा नोटेशन वी रिप्रेजेंट द लोअर बाउंड ऑन द फंक्शन रनिंग टाइम, and in the theta notation we will find out the average bound. ठीक है. So now let's understand this scenario. What is this? It is basically, what is the O of Gn? So it is a set of functions with smaller or same order of growth as Gn. जैसे I'm just talking about the suppose this O of n. So if this is the upper bound, then जो जितने भी एफ एन होंगे वो सारे के सारे फंक्शंस क्या होंगे, विल बी इक्वल टू और लेस देन टू दिस एन. इस सेट में जो भी फंक्शंस आएंगे, जैसे ये n है तो इसमें 3n+1 10 हो गया, 100n हो गया, 2n-1 हो गया, कांस्टेंट वैल्यू हो गई. इसके अलावा log n भी पॉसिबल है, बिकॉज द ग्रोथ ऑफ log n इज लेस एज कम्पेयर टू n. तो जो हमारा gn फंक्शन है, उस gn फंक्शन के जो सेट है, इसके अंदर जो फंक्शंस होंगे एफ एन, दोज विल बी लाइक दिस. मीन्स आई कैन से लाइक इफ सपोज दिस इज द जी एन, तो इफ एन स्क्वायर इज द जी एन, तो एफ एन की जो वैल्यू है ऑलवेज बिलो होगी. तो जो भी फंक्शंस की वैल्यू इस n स्क्वायर से बिलो हो सकती है, दोज कैन कम इन पर्टिकुलर सेट। जैसे ये एग्जांपल यहाँ पे n स्क्वायर वाला, so in the set of Gn, this is the n square, Gn is n square, so all the Fn will be like this. It can be 2n square minus tan n plus 100, it can be tan n plus 5, it can be a constant complexity, it can be like this. O of Gn में देखो क्या हो सकता है, O of n log n, O of n log n। अब ये जो फंक्शन मैं बता रहा हूँ, दिस वन जो हाईलाइटेड हैं और नोटेशन फॉर्म में हैं, these are the Gn, these all are Gn। and this is the upper bound, and this is the upper bound for all of these functions जो इस पूरे सेट में है। like for O of n log n, the upper bound can be 5n plus 10, means sorry, upper bound is n log n, so it can be possible for these functions 5n plus 10, tan n log n। तो हम क्या कर सकते हैं इसमें, इस फंक्शन ये जो अपर बाउंड है, इट कैन बी पॉसिबल फॉर ऑल द फंक्शंस which are which whose rate of growth is less as compared to this particular function. Now point is this, it can be the upper bound for this tan n log n minus tan n plus 1 or n log n plus 100n। बट ये इसके लिए अपर बाउंड कैसे हो सकती है, तो मैं बताता हूँ इसमें, ये पॉइंट हम क्लियर कर लेते हैं। व्हाट इज द बेसिक मीनिंग ऑफ अपर बाउंड? So in the case of upper bound, there will be a precise upper bound, means that will be the tight bound, means उससे ज़्यादा possible नहीं है, that will be the exact। but उसके आगे वाली भी तो सारी upper bound हो सकती है। like if I am talking about for n, तो इसके लिए जो upper bound है, for some combination of c and n naught, the upper bound can be n square। suppose we are having this function n, so if we are talking about the bound for this function n, then the upper bound for this can be in terms of n or n square or n cube or 2 raised to power n। upper bound तो है सारा का सारा ये, but these are not the precise। if we are talking about the precise, then this can be the precise, means for this function O of n can be the precise one। okay, so if suppose there is a question like is it true like fn equal O of, not it is not equal, n is order of n square, so it may be possible like for constant for some constant c and n naught जो हमारी inequality है, that will be true for this। so this can be the upper bound, but it is not the precise upper bound। okay, so here you can see here are several functions here in the set of Gn, like these are the Gn, so these can be the functions whose upper bound can be this। okay, now when simply we are denoting the functions in the mathematical notation or numerical form, तो क्या करना है, take the function fn and gn and consider only the most significant term and remove the constant multiplier। so suppose we are given a function like this 5, the question is represent this 5n plus 3 in big O notation। so this will be the fn, and what will be the gn? so we need to just take the most significant term, only the most significant term uh, apart from the multiplier, so we will take their n। so this is the function and this fn and this is the gn, this is the upper bound। अगर नहीं given है तो ठीक है, तो question can be like represent this in the asymptotic big O notation or find out the big O notation for this function। so in that case we can do assume it like this। अगर नहीं given है तो, या फिर given होगा, then question can be like this, prove that 5n plus 3 is the order of n or order of n square। तो ये fn हुआ and this will be the gn, and after that we will solve by using the rules and regulation of big O notation। वो question कैसे solve करना है, तो जैसे 5n plus 3 given है, then gn will be, this will be fn, this and gn will be n। like suppose ये given है, then n square is the most significant term, so gn will be n square। in this case n log n is the most significant term, then n log n will be the gn। okay, so after that finding the gn, we will then compare the functions, and if fn less than equal cgn, then fn is in order of 1। तो हमको ये इनइक्वलिटी प्रूव करनी है। उसके बाद जब हमने एफ एन और जी एन अज्यूम कर लिया, देन वी नीड टू प्रूव दिस and we need to find out the values of C and N naught in that case. Now, let's suppose this is the example here. So, we need to prove that n square plus n is equal order is order of n cube. So here, this one, this is the Fn and this is the Gn. So here we have Fn equal n square plus n and Gn equal n cube. Now, अब क्या करना है, जो हमारा एफ एन है बेसिकली, तो हमको इसमें जो इनइक्वलिटी है, इफ वी आर जस्ट राइटिंग इट इन द फॉर्म ऑफ बिग ओ नोटेशन, देन इट इज 0 लेस देन इक्वल एन स्क्वायर प्लस एन लेस देन इक्वल सी एन क्यूब। ये तो एन, ये तो जी एन है, देन वी ऑल्सो नीड टू एड हियर सी, दैट इज द कॉन्स्टेंट। So this inequality should be true for all n greater than equal n naught. So we need to find out the value of this n naught and this c. तो ये फाइंड आउट करने के लिए हमें क्या करना है, जो भी फंक्शन हमको गिवन हो, उस फंक्शन में जो लोएस्ट ऑर्डर टर्म्स हैं, वी नीड टू कन्वर्ट देम ऑल इन द हाईएस्ट ऑर्डर टर्म. So we can notice here, like for all n greater than equal 1, n will be less than equal n cube, less than equal n cube. So we can and also for all n greater than equal 1, n square will be less than equal n cube. It is clear. So we can simply convert them in the form of the gn, like n square plus n. So we will write it n cube, and this n we will write it n cube. So we will get 2n cube. Yeah. Okay. So this 2n cube is for all n greater than equal 1. So for all n greater than equal 1, the value of n square plus n is the order of n cube. For this value, n not equal 1, and for c equal 2, this is the value of the c. So इस तरह से इसमें हमको कैलकुलेशन करना है, like we need to find out the c. So this is the c, और ये हमारा assumption था like n greater than equal 1, और यहाँ पे true भी है, the values of n square will be always less than equal n cube. तो ये यहाँ ज़्यादा टिपिकल इसलिए नहीं था बिकॉज ये जो है प्रिसाइज बाउंड नहीं है, बिकॉज इसकी वैल्यू ऑलवेज इससे बिलो ही रहेगी फॉर ऑल n ग्रेटर देन इक्वल 1. ठीक है, बट वी नीड टू एक्सप्रेस दैट इन द फॉर्म ऑफ द बिग ओ नोटेशन. तो बिग ओ नोटेशन के लिए हो गया n नोट की वैल्यू तो 1 हो गई और c की वैल्यू 2 हो गई. तो फॉर n नोट इक्वल 1 और c इक्वल 2, so we cannot write it like this, n not equal 1. We can write like this for n greater than equal 1, and this is the n naught. मीन्स ये हमारा वो लिमिटिंग वैल्यू हो गई. मीन्स इसके बाद वाली सारी वैल्यूज के लिए, इस पर और इसके बाद वाली सारी वैल्यूज के लिए ये फंक्शन एफ एन की वैल्यू जी एन के ऑलवेज बिलो रहेगी ग्राफ में. ठीक है, एंड देन दिस विल बी द कांस्टेंट. नाउ this is another example, like show that 30n plus 8 is O of n, is the order of n. So how can we represent it like 30n plus n? So we will write it like this, 30n plus n, and we will convert it into first of all n. So 8 को replace कर देंगे n से, 30n plus n, that will be 30n plus n, this is 31. So the value of c will be 31. Okay, and now we need to find out the this value of the n naught. अब ये 8 कैसे आया है, I can just show you. हम एक एक्सेल में इसको रिप्रेजेंट करते हैं जिससे ये क्लियर हो जाए कि ये कैलकुलेशन कैसे हो रही है. तो फंक्शन हमारे पास है, एक फंक्शन है, इसमें हमारे पास इट इज 30n plus 8, and another function we are having cn. Okay, and the value of the c is 31. So 30n plus 8 and 31n, इन दोनों को रिप्रेजेंट करते हैं. And just give me a second, I'm just modifying this value. So we are having, this is fn, this is the growth of n, this is cgn, and I need to just modify it like this. एक मिनट, इसको मैं कॉपी कर लेता हूँ दूसरी शीट में. Okay, so here we are having 30 equal, sorry, it will be 30 multiply by, what is this value, c4. C4, okay, and plus 30n plus n, sorry, 30n plus 8, this one this, and ये वाली वैल्यू है हमारी 31n, so I can write it like this, 31 multiplied by C4. So एक में these are the all values. ओके, सो अब ये देखो, ये तो हमारा हो गया फंक्शन एफ एन, ठीक है, दिस इज द फंक्शन एफ एन, दिस इज द जी एन, ये हमारा था व्हाट इज दिस 30n plus 8 and this one is 31n, okay, so this is a means this is fn less than equal cn and the value of c is 31. Now we will just increase the value of n from top to down. हमने इंक्रीज 1 के लिए चेक किया, वैल्यू ऑफ एफ एन इज 38, इसका है 31, हमारा इनिक्वालिटी क्या है, द वैल्यू ऑफ 30n plus 8 मस्ट बी कैन लेस देन इक्वल 31n, तो हमको ये चेक करना है, ये तो सी हो गया कि किस एन नॉट की वैल्यू के बाद ये हमारा इनिक्वालिटी ट्रू होगा, तो यू कैन सी हियर व्हेन वी आर जस्ट इंक्रीजिंग द वैल्यू ऑफ एन, तो 1 के लिए फॉल्स है, 2 के लिए फॉल्स है, मैंने ये डिफरेंट कलर में कर दिया है, और इसको भी मैं थोड़ा सा जस्ट गिव मी अ सेकंड, आई एम जस्ट यूजिंग अ डिफरेंट कलर हियर, नॉट ग्रीन, ऐड कर लेते हैं इसको, और इट इज FALSE फॉल्स, ओके, और इसको कर देते हैं हम यहाँ पे ट्रू, और यू ले लेते हैं हम ग्रीन, ओके, ओके, अब ये क्लियर हो जाएगा, तो वी कैन सी हियर फॉर n equal 1 इट इज फॉल्स, 2 फॉल्स, 3 फॉल्स, 4 फॉल्स, 5 6 7 7 तक इसकी वैल्यू वेरी कर रही है, और बोले तो एफ एन की वैल्यू ज़्यादा है, इससे बड़ी होनी चाहिए, इससे कम, बिलो, तो यू कैन सी हियर एट दिस पर्टिकुलर पॉइंट एन नॉट इक्वल 8, इन दोनों की वैल्यू इक्वल है, और इसके बाद वाली सारी वैल्यूज के लिए फंक्शन एफ एन की वैल्यू जो है जी एन से कम है। मैंने यहाँ पे क्या किया है, सिंपल एक यहाँ पे फिल्टर फॉर्मूला लगाया है, G11 ग्रेटर देन इक्वल E11, तो ये वाली जो वैल्यू है हमारी, ये वाली इस वाली ई वाली सेल की वैल्यू से ज़्यादा हो या बराबर हो तो इट विल बी ट्रू, ओके, सो नाउ यू कैन सी हियर व्हाट इज द आउटपुट फॉर n नॉट इक्वल 8 और उसके आगे वाली सारी वैल्यूज के लिए, you can see here it is true, okay, so we get from here, and for this inequality the value of c equal 31 and the value of n naught greater than equal 8. Now what will be the answer? So 30n plus 8 is the order of n, like this. So for c equal 31 and n not equal 8, 30n plus 8 is the order of n. Now ये उसका graphical representation है, like this is the value of n naught, and at this point the value of n naught is 8 at this point. So इससे पहले क्या था, function gn की value जो थी, it was below the function fn, and after this n naught for c equal 31 the value of the function fn is always below, this is the fn, okay, and this is the gn, ये इससे always above है, इसके बाद fn की value below है, gn की above है, okay, so 30n plus 8 isn't less than n anywhere, it isn't even less than 31n everywhere, but it is less than 31 everywhere to the right of n greater than n equal 8, means after this, इसके बाद वाली सारी values के लिए fn is always less than to gn. So this is the way how we can represent the time complexity in big O notation. अब कुछ क्वेश्चन और सॉल्व करते हैं, like We are having this question, fn equal 27n square plus 16n and gn equal O of n square. अच्छा, या तो इस तरह से क्वेश्चन गिवन होगा एंड वी विल यू आर जस्ट आस्क्ड टू रिप्रेजेंट द सेम इन द बिग ओ नोटेशन, या क्वेश्चन ऐसे गिवन होगा 27n square plus 16n is the order of O n square, prove it. Means we simply need to find out the value of the constant C and N naught. So now, as per the big O notation, Fn and Gn, this is the Fn and this is the Gn. So 27n square plus 16n must be less than equal Cn square. तो हम क्या करेंगे, फॉर ऑल n ग्रेटर देन इक्वल 1, 16n की जो वैल्यू है लेस देन इक्वल n स्क्वायर, सो वी विल रिप्लेस दिस 16n विद n स्क्वायर. तो हमने इसको n स्क्वायर से रिप्लेस किया बिकॉज इट इज ट्रू. तो 27n स्क्वायर प्लस n स्क्वायर लेस देन इक्वल cn स्क्वायर एंड इट विल बी 28n स्क्वायर. सो फ्रॉम हियर बाय द कंपैरिजन वी कैन सी हियर द वैल्यू ऑफ c कैन बी 28. So value of c is 28. Okay, and now we need to find out the value of n naught. I can just give you a hint in this. So you can see here in this previous example, n naught की वैल्यू क्या आ रही थी, और ये जरूरी नहीं हर बार ट्रू हो, it can be false, but in maximum cases you can find out the value of n naught by that. So second highest order, this is the first highest order term with power 1 n raised to power 1. It is the second highest order term with n raised to power 0. तो सेकेंड हाइस्ट ऑर्डर टर्म का जो कोफिशिएंट होगा उस कोफिशिएंट के आसपास वो वैल्यू आपको मिलेगी. ठीक है, तो लेट्स सपोज इट इज 8, देन वी कैन चेक स्टार्टिंग फ्रॉम 7. तो 7 के लिए चेक करो, 7 पे फॉल्स है, फिर 8 के लिए चेक करो, 9 के लिए करो, 10 के लिए करो, देन इफ इट इज ओके देन वी कैन राइट लाइक n नॉट विल बी 8. ऐसे ही ये रिप्रेजेंटेशन हमारे पास है. तो यू कैन सी हियर द हाईएस्ट ऑर्डर टर्म इज n स्क्वायर एंड सेकेंड हाईएस्ट ऑर्डर टर्म इज n. इसका मल्टीप्लायर है 16, तो इसका आंसर भी 16 के आसपास ही हमको मिलेगा. बट इसको हम एक बार चेक कर लेते हैं कि ये सही है. 27n स्क्वायर प्लस 16n और ये है 28n स्क्वायर. तो now what is this? It is not this. I need to modify this one. ओके, तो मैं इसको मॉडिफाई कर देता हूँ. इट इज 27n स्क्वायर प्लस 16n. इट विल बी 27 multiply what is this c4 multiply c4 20 plus 16 multiply c4. ओके, ये तो हो गया fn और इसको हम स्लैश कर देते हैं, इसकी सारी वैल्यूज मॉडिफाई हो जाए. नाउ व्हाट अबाउट gn? इट इज 28n स्क्वायर. ओके, it is 28 multiply c4 like this. तो एक मिनट, इसको रीस्टैश किया हमने और इसको भी स्टैश किया. नाउ यू कैन सी हियर. तो देखो हमारे पास दो फंक्शन है यहाँ पे. व्हाट आर द फंक्शन नेम्स? द फर्स्ट फंक्शन इज इट इज 27n square plus 16n. It is our fn. And another function is 28n square, है ना? So this will be like this in the big O notation, and this value is the value of c. Okay, now we need to, this is gn, this one is gn basically. N square is gn, not the whole thing. Okay, this one is the gn. So अब हमको क्या करना है, n नोट की वैल्यू फाइंड आउट करनी है. तो मैंने बोला कि सेकेंड हाईएस्ट ऑर्डर टर्म का जो मल्टीप्लायर है उसके आसपास हमको वैल्यू मिलेगी. बट ये मैं आपको एक्सेल में इसलिए दिखा रहा हूँ, लाइक आप लोग चेक तो कर नहीं सकते वहाँ पे लाइक दिस, बट यू मस्ट बी अवेयर कि होना क्या है. तो यू कैन सी हियर इन दिस वन, मैं थोड़ा इसको छोटा कर देता हूँ. तो for I equal 1 to I equal 15, you can see here the value of the CGN is less than to value of the FN. मतलब ये जो वैल्यू, ये इनइक्वालिटी ट्रू नहीं हो रही है, बट यू कैन सी हियर आफ्टर द एट n इक्वल 16 दोनों की वैल्यू इक्वल है 7168 एंड 7168, ठीक है, एंड इट इज ट्रू। और इसके आगे वाली सारी वैल्यूज के लिए ये gn की वैल्यू fn से ज़्यादा है, cgn की वैल्यू fn से ज़्यादा है, यू कैन सी लाइक दिस, ठीक है। सो what can be the value of n naught? It will be n naught will be greater than equal 16, and the value of c, so we can write it like this: for c equal 28 and n naught greater than equal 16, we can write it like 27 n square plus 16 n is order of n square. So this is the answer. This is the answer for this question. Okay. तो यहाँ मैंने ये आपको वहाँ पे कुछ वेरिएबल्स की वैल्यूज के लिए वहाँ पे n की वैल्यूज के लिए शो करना है कि क्या वैल्यूज हैं, लाइक व्हाट इज द वैल्यू ऑफ n नॉट, कैसे हमने कैलकुलेट किया। तो वी कैन स्टार्टिंग फ्रॉम लाइक n इक्वल 15 16 17 18, देन वी कैन राइट दिस वन। ओके, तो लेट्स टेक अनदर क्वेश्चन। 27 n स्क्वायर प्लस 16 के लिए ये आंसर आ रहा है, बट नाउ फॉर 27 n स्क्वायर प्लस 16 कर देते हैं इसको, देन व्हाट विल बी द आंसर, वी कैन विल चेक हियर। तो इट इज fn 27 n square plus 16, gn is n square. So as per the big O notation, fn must be less than equal cgn for some constant c and n naught. ये हमने यहाँ पुट किया. Now we simply convert it into n square, because for n greater than equal 1, 16 will be less than equal n square. So it we replaced it by 28. So the value of c is 28. Now what about the value of n naught? इस केस में n naught की वैल्यू क्या होगी, ठीक है, ये देख लेते हैं कितना चेंज आएगा। जैसे ये हो गया, इसी को कॉपी कर लेता हूँ और मैं मॉडिफाई कर देता हूँ। दैट विल बी शीट 2 को कर रहे हैं हम, शीट 1 2, इट इज अ शीट, सॉरी, create a copy. ओके, तो देखो ये नहीं है, ये भी नहीं है, ठीक है, इसको हटा देते हैं यहाँ से। So I'm just modifying the value of this function fn. It is only 16 here rather than this, ठीक है, और ये वही रहेगा। तो एक मिनट, now the function is 27 n square plus not 6, it is 16, ठीक है, और ये हो गया हमारा यहाँ पे gn, ये यही है। तो यू कैन सी हियर द वैल्यू, द फंक्शन fn क्या है, fn is 27 n square plus 16 and gn is n square. Okay, and we need to express all of them in the notation 27 n square plus 16 less than equals 28 n square. So this is the c. Now we need to find out the n naught. तो यहाँ पे देखो कितना चेंज आ रहा है, the value of the n naught is 3, मीन्स इससे पहले, इसके आगे भी देख लेते हैं कहाँ तक है, लेकिन देखो सब जगह ट्रू आ रहा है, मीन्स बस इससे पहले पहले फॉल्स आ रहा है, 3 से पहले पहले। तो द वैल्यू ऑफ n नॉट विल बी ग्रेटर देन इक्वल 3 and the value of c is 28. So for this we can say 27 n square plus 16 less than not less than, it will be order of n square. So this is for this. Now let's take another question. The question is, find out the big O notation for 4n cube plus 2n plus 3. So fn is 4n cube plus 2n plus 3. So gn क्या हो जाएगा? That will be the highest order term, like that is n cube. So this is the gn. So simply we will replace these all values into n cube. तो हम सबसे पहले क्या करेंगे, इसको n में कन्वर्ट करेंगे, देन जो n आ जाएगा उसको n क्यूब में कन्वर्ट करेंगे. तो फॉर ऑल n ग्रेटर देन इक्वल 3, 4n cube plus 2n plus 3, it will less than equal 4n cube plus 2n plus n, because we are replacing 3 with n. ये true होगा. Okay, so it will be 4n cube plus 3n. Now for all n cube greater than equal 3n, 4n cube plus 3n will be less than equal to 4n cube plus n cube. So it will be 5n cube. So the value of c will be 5. Now we need to find out the value of the n नॉट की, किस n नॉट की वैल्यू के बाद ये हमारा inequality 2 होगा. ओके, तो ये है 4n क्यू प्लस 2n प्लस 3 एंड ये है हमारे पास 5n क्यू. तो मेरे पास इसका फंक्शन है पहले से, ये रहा 4n क्यू प्लस 2n प्लस 3, 4n क्यू प्लस 2n प्लस 3 और 5n क्यू. तो इट इज 5n क्यू, इट इज 4n क्यू प्लस 2n प्लस 3. ओके, तो देखो यहाँ क्या वैल्यूज आ रही हैं हमारे पास. अब मैंने पहले क्या ट्रिक बताई थी आपको. द ट्रिक वाज द वैल्यू ऑफ n नॉट विल बी नियरर टू द सेकेंड हाईएस्ट ऑर्डर टर्म मल्टीप्लायर. सेकेंड हाईएस्ट ऑर्डर टर्म का मल्टीप्लायर क्या है, ये है यहाँ पर 2. ओके, सो 2 एंड इट इज 2. यहाँ पे देखें इसमें क्या वैल्यू आ रही है. तो फॉर ओनली n इक्वल 1, ये इनइक्वालिटी गलत है, मीन्स 5 इज लेस देन n, ये नहीं होना चाहिए, 5 ग्रेटर देन n होना चाहिए. एंड फॉर ऑल वैल्यूज, जो इससे आगे की सारी वैल्यूज हैं, यू कैन सी हियर द वैल्यू ऑफ CGN इज ऑलवेज अबोव FN. ओके, so we are having here FN equal 4n q plus 2n plus 3 and we are having gn equal n cube. So as per the big O notation क्या होना चाहिए, 4n cube plus 2n plus 3 less than equal cn cube. Okay, and cn cube, and what is the value of c, हमारे केस में यहाँ क्या है, ये है 5. and what is the value of n naught, it is greater than equal 2. 1 पे नहीं है, 2 से हो रहा है सारा ही. so for this n naught greater than equal 2 and for this 5, what is the relation in between them, 4n cube plus 2n plus 3 is the order of n cube. This is the relationship in between these two functions. In the previous class, we have discussed some problems related to the big O notation. So the same like the big O notation, the omega notation is basically represent the lower bound on the running time. And if we are given two functions, then how can we represent those functions in this big omega notation? So this is the inequality for big omega notation. Like we are having two functions, fn and gn. We are given these two functions. So we need to find out one positive constant c and an integer n naught for proving this inequality. And if it holds for a combination of constant and integer n naught, then we can say fn is omega of gn. So if we are given a function fn, then we need to represent it into, if we need to find out the big omega notation for that, then we need to find out the this set of constant and integer which satisfies this inequality. And if we are able to find such type of combination, then we can say that we can represent that particular function in that notation. So this was the graph. So this is that particular limiting point, after which the function's behavior will be like this. means this function's fn will always be above this function gn like this. Now let's take one example. So suppose we are given a function fn that is 2n plus 3, and now the question is represent this in the big omega notation or find out the big omega notation. So we are given initially this function 2n plus 3. Now there is no function gn is given in the question. So in that case, we need to assume the particular another function. So the gn will be, now here we are just finding the lower bound. So just remember the value of the gn must be less than equal to this particular function. So it will be less than equal, then we can take the function gn to and the power of n equal to the highest order term in this function fn or any less value related to this. So as here you can say here the highest order term is n, so we can take g of n equal n because we are defining the lower bound and we are given a function 2n plus 3, so we cannot take the function gn as O of n square because that particular higher value will always above this particular function for higher values of n. So whenever we want to find out the upper bound, then we can take any higher order term function or equal or higher order term function. And if we are finding the lower bound, then we can take equal and lower order term function. So here we are finding the lower bound, so we will take the gn as n equal, and normally we take this equal to n. Sorry, not equal to n, equal to the highest order term of the function. As the highest order term in this function is n raised to power 1, so we'll take gn as n. Now, as per the omega notation inequality, so this is the omega notation inequality, 0 less than equal cgn less than equal fn. Now, what we can do here, we simply put the value of fn and gn. So it is 0 less than equal cn less than equal to n plus 3. So now we need to find out the combination of c or n naught for which this inequality holds. And if we are able to, we will be able to find out that, then we can say this particular function is omega of n. So now you can see here, it is cn, it is 2n plus 3. So suppose I'm just taking the value of c is 2, or the value of c in the case of omega notation can be taken as slightly smaller or equal to the highest order coefficient multiplier of the highest order term and the function fn. Like this is the multiplier of the highest order term. This is the highest order term and it is the multiplier 2. So the value of c can be taken as equal to this or less than this. But it is not true always. We need to look at the situation. Like here it is 2n plus 3, and this 3 will always be added into this 2n. And if I am just taking c equal to, then 2n less than equal to n plus 3 always, because this 3 will be added to this 2n. But assume like it is 2n minus 3, and in that case I cannot take the constant c value to here. I need to take some smaller value as compared to this function, so that this inequality can be satisfied. So in this case, the value of c can be taken 2, so it is 2n less than equal to n plus 3, and it will be true for all the values of n naught greater than equal 0. And I have already told you the value of c and n naught is not fixed, are not unique until unless we are given some base condition. So in this case, in the question, we are not given any base condition. We're just given a function. So there can be there can be several combinations of c and n naught. Means I can take c equal to and n naught greater than equal 0. I can take any value less than to 2, c less than equal to, c equal to 2, c equal 1, c equal 1 by 2, 1 by 4. Okay, and suppose 3 by 2. any value less than to this. So for those all values of c, it will always hold true. So for this particular function 2n plus 3, the value of c will be equal to 2 and n not greater than equal 0. Means for this combination we can say 2n plus 3 is omega of n, and there can be several other combinations. Okay, so I'm just repeating it. Whenever we are given a function and question is like represent, and they are asking to represent a particular function in the omega notation, then just write down the function and assume the another function, that is gn, and gn will be equal to the highest order term in the function fn. Like here it is 2n, then it will be n. Not 2n, it is n raised to power 1, then gn will be n raised to power 1. Let's suppose it was 2n square plus 3, then we can take here gn equal n square. So then we need to show the functions in the inequalities to that particular notation. So in the case of omega notation, the inequality is this. So we just put all these values here, and here we just calculated all the values for which this inequality holds. Okay. So in this question there is no problem, because for c equal to and for any value of n greater than equal 0, it will always be true. Now let's take another question. Suppose we are given this 4n cube plus 2n plus 3. Now we need to find out the big omega notation, or we want to represent this in the big omega notation. So we are given function this 4n cube plus 2n plus 3, and now we need to assume the other function, that is gn. It will be equal to the highest order term in the function fn. So gn will be n cube, as the highest order term in this function is n cube. Now as per the rules and regulation of big omega notation, this inequality should be satisfied. 0 less than equal cgn less than fn. So we can just put these values, function fn and gn here. So 0 less than equal cnq less than equal 4nq plus 2n plus 3. So for c equal 4 and n not greater than equal 0, you can say 4nq plus 2n plus 3 is omega of nq. So you can see here it is 4nq and it is 4nq plus 2n plus 3. I can take the value of c less than equal 4, means 4 or all the values that is less than to 4. It will be true for all the possible combinations of this c less than equal 4 and n not greater than equal 0. It will always hold. So we can have several combinations for this also. So this is the omega notations. Now one more thing, like we are given this function 5n square. So the lower bound for this function can be omega of n. Okay, but I'm just writing here like 5 of n square equal omega of n cube. It will not be true, because how the lower bound for this particular function n square is n cube. It is not possible. Okay, so whenever we are just finding the lower bound, then the lower bound can be like for the 5n square, the lower bound can be omega of n square, or omega of n, or omega of log n. I means any function which is smaller, whose growth is smaller as compared to the function in the function fn. Okay, so for n square, the lower bound can be, a function can be taken n square, n log n, and n log n. Okay, all the function which are whose growth is less than to n square.
So
like for n, suppose we are given n, so for this n we can say like the lower bound for this n can be omega of n, or omega of log n, like this. Okay, or omega of as the it is dependent on input, so we cannot take the constant value. And suppose we are given the function it is n q, then for this lower bound can be n q, omega of n square, omega of n, omega of n log n, and all the smaller functions. But now you can just look at here, we are given this function 100n plus 5. So it is not possible. It cannot be the lower bound for this function. it can be the upper bound only. We can say like this, it can be O of n square. Okay, so upper bound can be possible this, or we can say equal O of n, or n is smaller value, but it cannot be possible. Okay, so like this, for n it can be omega of 2n, for n cube it can be omega of n square, for n it can be omega of log n. Now that was about the big O notation and omega notation, lower bound and upper bound. Big omega notation was defining the upper bound on the function running time, and omega notation was defining the lower bound on the function running time. Now we are having a combination of both the notations that denotes the average case time complexity of the algorithm, or in other words, it represents the upper and lower bound on the running time of the algorithm. Okay, so as it is expressing both the bounds, like if we want to represent it like this, suppose it is fn and it is for upper bound less than equal cgn. Okay, and for the lower bound it can be cgn and it is 0, but we are defining two bounds. It is the upper bound and it is the lower bound. So we need two constants here. It will be C1 and it will be C2, but this n will be same, means the limiting value of n after which this inequality will solve, means after which this function fn, okay, will be enclosed by C1gn and C2gn from below and above. It will be the lower bound, it will be the upper bound. So for this theta notation, we need to find out, if we are given a question or a function, then we need to find out the constant C1 for lower bound, or constant C2 for upper bound, and an integer n naught. So it will be taken as common for both the bounds. So we will solve such type of questions separately. We will find out the lower bound constant combination C1 and n naught for this, and then we will find out for upper bound combination of C2 and n naught, and after getting that, suppose we find out n naught for this and n naught for this. So if from these two n naught we will take the highest one, or that particular for which both the inequalities holds true. Okay, so like this is the limiting point here and not. So after this particular limiting point, you can see here this functions, lower bound functions, is always below the function fn, like this. It is below the function fn, and after this the C2gn is above the function n. So C2gn is defining the upper bound and the C1gn is defining the lower bound. Okay, so now let's understand the concept with the help of some example. Suppose we are having a function, again the function fn equals 3n plus 2. Now find out the theta notation. So what we are given? We are given fn equals 3n plus 2 and gn we need to assume here. So gn, for the gn we can take it is equal to the highest order term in the function fn. So this is the highest order term, that is n, so we can take the gn equal to n. Now as per the theta notation, so what theta notation says, it is like this: 0 less than equal C1gn, less than equal fn, less than equal C2gn. Okay, now we can put the values of fn and gn here. So it is 0 less than equal C1n, less than equal 3n plus 2, and less than equal C2n. Okay, now we need to find out the values of C1, C2 and n naught, for which this inequality holds true, and only in that case we can say 3n plus 2 equal theta of n. Okay, so let's take a look at here. C1n less than equal 3n plus 2. So I can take the value of C1 less than equal to 3. If I can just, I'm just taking the C1's value 3, then it will be 3n less than equal 3n plus 2. And it will be true for all the values of and not greater than equal 0. Okay, it will be true for just a second, it will be true for and not greater than equal 0. So for C1 equal 3 and not greater than equal 0, this will be always true. Okay, so we have found out the combination of C1 and not for this lower bound. Now we need to find out the combination of C2 and not for this. Okay, so 3n plus 2 less than equal C2n. So you can see here it is 3n plus 2 and it is C2n. So if we want to find out the value of C2, in the case of theta notation, we can take the value of the C1 just slightly less than to the coefficient of the highest order term, and the value it is the coefficient, sorry, value of C2 will be slightly higher than the value of C1 will be slightly less than to this coefficient multiplier, and value of C2 will be slightly higher. Okay, so in the case of upper bound, it will be slightly higher though. I can assume like I'm just taking the value of C2 equal 3. So 3n plus 2 less than equal 3n, it will not be true. So I need to just change the value of C2. So I assume like the value of C2 is 4. The value of C2 is 4. So 3n plus 2 less than equal 4. So it is like 3n plus 2 less than equal 4. Okay, so we can sorry, less than equal 4 less than equal 4 and so like just check these values for and not equal 0 0, sorry, it is 2 less than equal 0, it is not true, and not equal 1, it will be 3 plus 2 or 5 less than equal 4, no, and not equal 2 के लिए हो गया 3 to the 6 plus 2 8 8 less than equal 4 to the 8, so 8 equal 8 ये तो इक्वल आया यहाँ पे, ठीक है. Now for n not equal 3, it will be 9 plus 2, it will be 11 less than equal 12, true. N not equal 4, it will be 12 plus 2 14 less than equal 16, so it is true. So it is true for all the values n not greater than equal to. Okay, now we have find out the values of C1, C2 and separately n naught for both these inequalities. Just a second. Okay, so we have find out the combination C1 equal 3 and n naught greater than equal 0, C2 equal 4 and n naught greater than equal 2. So you can see here this inequality also holds for n not greater than equal to, as it is holds for n not greater than equal 0, but it is not, this one is not holding for n not less than 2. So we will take the n not as n not equal to. Okay, so we find out the value C1 equal 3, C2 equal 4 and n not equal 2, and for this combination of these constants and this integer, we can say 3n plus 2 equal theta of n. Okay, so this is the way by which we can calculate the theta notation. Means we need to find out the set of combination of constant integer for lower bound as well as for the upper bound. Now let's take another example, like we are having this one, fn equals 7n plus 5. Now you can easily solve this one. Okay, so we need to represent it in theta notation. So we are given here fn equals 7n plus 5 and gn equal n. We are assuming this gn equal n. Okay, because the highest order term coefficient in the function fn is n raised to power 1. So we are just taking it gn equal n. Now as for the theta notation, it will be 0 less than equal c1 gn less than equal fn less than equal c2 gn. So just put the values of fn and gn here. So it will be 0 less than equal c1n less than equal 7n plus 5 less than equal c2n. Okay. Now we need to find out again the combination. So it is c1n less than equal 7n plus 5. So you can easily see that the value of c1 can be less than equal 7.
Means we can take the value of C1 as 7 or all the values less than to 7 but greater than 0. Okay. So because the constant should be positive. So we are just taking C1 equals 7 and now it is 7n after taking C1 to 7, 7n less than equals 7n plus 5. So it will always true for n not greater than equals 0. Okay, it will be true for n not greater than equals 0. So we have find out the constants and integer value for this combination. Left one, lower bound. Now for the upper bound, this one, 7n plus 5 less than equal C2n. We need to find out that. So we need to assume we cannot take C2 as 7 because it will dominate to this and this will grow faster as compared to this. So we can take the constant C2 value slightly higher than the coefficient of the highest order term. It is 7, so we will take it 8. Okay, so see, we have taken C2 equal 8. So for C2 equal 8, it will be 7n plus 5 less than equal 8n. Now we need to find out the value of n naught. Okay, so for n equal 1, it will be 7 into 1 plus 5, 12, and it will be 8 into 1, 8. So it doesn't solve true. Now for n equal 2, it will be 7 to the 14 plus 5, 19. It will be 16. 19 less than equal 16. No. N not equal 3. It will be 7 3 the 21 plus 5. 26. And it will be 8 3 the 24. 26 less than equal 24. No. For n equal 4, it will be 7 to the 7 4 the 28 plus 5. That is 33. And it will be 32. 8 4 the 32. So n not equal 4, it is not true. N not equal 5. 7 5 is 35 plus 5, that is 40, and 8 5 is 40. Now just check for some more values of n. For n not equal 6, like assume I'm just taking for n not equal 6, it will be 7 6 is 42 plus 5, that is 47 less than equal 8 into 6, that is 48. So it is growing. Okay, for n not equal 7, it will be 7 7 is 49 plus 5, that will be 54, and here it will be 56. Okay, again it is higher. So what is the limiting point? The limiting point is n not equal 5. Means after this n not equal 5, this function fn, sorry, g2n will dominate this one. So we have find out two combination, c1 equals 7 and n not greater than equal 0, and another combination is c2 equal 8 and n not equal 5. Okay, now you can see here it is true for n not greater than equal 0, but it is not true for n not less than 5. So we need to take this n not value a single value, so the value can be taken as n not equal 5. So the final combination is c1 equal 7, c2 equal 8, n not equal 5. So 1n plus 5 is theta of n. Okay, so these were some simple examples. Okay, now let's take some little there's some change, like we are just taking negative here, negative sign here. So in place of positive sign, we are just taking negative sign here. Okay, so we are given fn equal half of n square minus 3n, and we need to find out the theta notation. Just a second. Okay, so we are given a function, this half of n square minus 3n. So we need to assume the gn. So gn will be equal to the highest order term of this function fn, that is n square. So we have taken the gn as n square. Now as per the theta notation, this is the inequality 0 less than equal c1 gn less than equal fn less than equal c2 gn. Let's put the values here. So it is 0 less than equal c1 n square less than equal half of n square minus n, this is fn, and less than equal c2 n square. Okay, so we need to find out the values of c1, c2, and n naught. So you can see here c1 n square less than equal. Now let's take
into consideration this one first. C1 n square less than equal half of n square minus 3. You can see here, if just I am taking the value of C1 equal to 1 by 2 or half, then 1 by 2 n square less than equal 1 by 2 n square minus 3n, which is not possible, because for all values of n, this will be lesser as compared to this. Means we cannot take the value of C1 equal 1 by 2, but in the previous question, it was possible, like we can take the value of C1 to the equal to the highest order term coefficient. So it depends on the situation. Okay, so here we need to take the value of C1 slightly less than to this particular value of highest order term coefficient, means half. So we can take a slightly less than value to this half. So we can take C1, assume like we are taking C1 equal 1 by 4. So for C1 equal 1 by 4, okay, it will be 1 by 4 n square less than equal 1 by 2 n square minus 3n. Now we need to find out the value of n naught for this combination. Okay, what is this? 1 by 4 n square less than equal 1 by 2 n square minus 3n. Now suppose I am just finding it for n equal 1, then it will be 1 by 4 less than equal 1 by 2 minus 3, which is not possible. Okay, now for n equal to, it will be 1 by 4 and into 4 less than equal, it will be 1 by 2 into 4 minus 3. So it will be 1 less than equal 2 minus 3 minus 1, not true. Now take for n equal 3, it will be 9 by 4 less than equal 9 by 2 minus, okay, I'm just not taken value here, it will be 6, 3 to the 6. So 9 by 2, and here n equal 3. So it is 9 by 2 minus 9. So you can see here it is not also possible. Okay. So there is a trick for this. Whenever we are just finding the value of the n naught, then we need to check for some of the higher values, like you are not able to find for this, then just check for a little higher value, and if it is true, then just go back to the previous one, means we need to find out the boundary condition or the limiting value, means after that particular value the condition will always true. So suppose I'm just checking from 1, 2, 3, 4, it is not true. So just take, suppose I'm just taking randomly the value for 10. Yes, so suppose it is for 15. So it is true for this, then just go back to the previous one, just check for 14. If it is true, then just go back for this, like this. If it is true, or suppose for 12 it is false, then the value of n naught will be greater than equal 13, means the limiting value will be 13, like this. Okay. So these are not true for this. So it means I need to take the value of n naught a little higher as compared to this. So suppose I'm just taking the value of n naught equal 10. Okay. So it is, it will be 100 by 4, mean that is 25 less than equal, it will be 50. Okay. Or minus 30. So 25 less than equal 20, it is not true. For 11, it will be, no, suppose I'm just taking for, okay, so I'm taking 11, it will be 121 less than equal, sorry, not 120, 121 by 4 less than equal 121 by 2 minus 30. So suppose I'm assuming it 120, so it is 30, it is 60 minus 30. Okay, so 30 less than equal 30, but actually it is not 30 na, in this case. So we cannot take the value here because this will be lesser as compared to this. We can go for another value. suppose n equal 12, it was 121. N equal 12, it will be 144 by 2 less than equal, sorry, 144 by 4. Okay, and it will be 144 by 2 minus, I'm taking this value wrong here. It is not 30, it will be 33. तो 33 होगा तो क्या होगा, हाँ सही है, 33 होगा तो भी ये इसके इक्वल नहीं आएगा, ठीक है, ये लेसर होगा, लाइक हम जस्ट इट विल बी 4 3 जा 30, यहाँ तो 30 आएगा और यहाँ पे 60 माइनस 33 तो भी लेसर होगा. फॉर n नॉट इक्वल 12 इट विल बी 12 raised to power to 144 divided by 4 less than equal 144 divided by 2 minus 36. ओके, सो ये हो गया 4 3 जा 12 एंड 4 6 जा 24. तो 36 ये तो हो गया 36. Suppose it is 36 less than equal, it will be 74 minus and it will be again 36. Okay, so 74 minus 36, so we can get here 8 and 3, 38. Okay, so it will be 36, it will be 38. So this one is the limiting value. इसके बाद ये यहाँ पर इसकी value always इसके above होगी. Okay, so this one is the limiting value, n not equal to 12. So we need to find out this. So I'm just erasing this as we have find out the value of n naught for the lower bound only. So we have just taken consideration of lower bound. You people can use calculator for fast computation over there. So C1 equal 1 by 4 and n naught equal 12. Now this was for this means lower bound. Now for this one means for this upper bound, like this one. So half of n square minus 3n. What can I do here? C2, I can take the value of C2 equal to half. So it will be half of n square. So this will be subtracted from half of n square. So it will always be lesser than to this half of n square. Means if I am just taking the value of C2 half, so half of n square minus 3n less than equal half of n square. It's always true for all the values of n naught, means for n not greater than equal 0, n not greater than equal, you can say 1. Okay, so this will true for Cu2 equal half and n not greater than equal 1. So we have find out two combinations, C1 equal half and n naught equal 12 and C2 equal half and n naught equal 1. But we need to, okay, as this inequality will not be true for n naught less than 12. So we, but this can be true for n naught greater than equal 12. So we can take the value of n naught as 12. Okay. So C1 equal 1 by 4, C2 equal 1 by 2 and n naught equal 12. For these combination, we can say half of n square minus 3n equal theta of n square. This is the proof. Okay. So I've just not shown the calculation here. You people are required to show all the calculation whenever there is a question in the examination. You need to just show how you have find out the value. Why? So because of the limitation of the space, I'm just showing the calculation here. So these are some of the examples for theta notation. This is another question. आप लोग इसको देख लेना एक बार. इसमें अगर कोई डाउट होता है, then you people can ask me. Okay, I will explain you that. इसके लिए the value of C1 and C2 are these, and just check for which combination these values are always true. So for this one, if we want to represent it in theta notation, C1 will be 1 by 4, C2 will be 1 by 2, and n naught will be 2 or greater than equal to 2. Okay. So if we are given a function n, it will not be theta of n square. I have already told you about this. Whenever we are just finding the notations or denoting the functions in terms of notation, then always just remember this: if we are talking about the upper bound, then the value of the gn will be equal to and greater than to the function fn. So we need to take higher order terms coefficient for that, higher order terms of n, and for omega notation we need to take the value of gn lower or equal to the higher order highest order term of the function fn. And in the case of a theta notation, the growth of the functions is same always. So we need to take the that is equal coefficient, like it is n square by 2 minus n by 2, then we can take n square as the gn. Okay, so ये चीज थोड़ा ध्यान रखना, otherwise you will not be able to find out the combinations of C and N naught for such cases.